Okay, welcome back. This is a lesson on electrons. Okay, so valence electrons are electrical for the outermost energy level of an atom. Okay, valence electrons. We covered a lot of this previously, but let's review. Column 1, alkali metals, they all have 1. Column 2, alkali earth metals, all have 2. Column 12, column family group 13 has 3, 14 has 4, 15 has 5, 16 has 6, 17 has 7, 18 will have 8 except for helium only has 2, okay? Everybody else has 8, but helium has 2 because that's all it's got. Remember, the first shell, the first energy level, it only takes 2 electrons to be full. So helium is a full first level, which is only 2 electrons. That is why it is a noble gas like all the other ones. They have a full outer shell. So transition metals, they do have valence electrons, but they vary. They vary because it has different set of properties. And so we don't worry about transition metals here. We're only worrying about main group elements. Main group elements, representative elements. If you look at the periodic table, you have C1A, 2A, 4A, all the way to 8A there. That part means it is the main group or representative elements. Okay. Another way to think about it is just look at the ones in the number. Like group 1 is 1, group 2 is 2, group 13 you drop the 1 in front and then you have your valence electron. Okay, so it's fairly easy. So simple question is, with your handy dandy work here, nitrogen. So look at nitrogen on group 15 here. So it'll have 5 valence electrons, right? So it's group 15, 5 valence electrons. And you look to the right of it, fluorine, group 17, it has group 17. So group 17 has 7 valence electrons. All right. So the way you draw the Lewis dot is very, very simple, guys. We're just counting to 8 electrons. Okay. Don't draw the total. Don't draw the total. Don't draw an X on yours, but I'm just using it for emphasis here. Okay. So 5 valence electron. You draw nitrogen. Write the symbol, and you pick a side to start. It's going to be top, bottom, left, right. I typically start on the right and go 1 dot, 2 dots, 3 dots. So north, south, east, west, only those 4 sides. And then you start pairing them when you get to the 5th one. You most of the time you don't pair them until you get to the 5th one. Most of the time, and I'll show you an exception in a little bit. Okay. So yeah, that's it. 5 dots around the nitrogen to show the 5 valence electron. This is important because later on our bonding unit, you know that there's something that's going to bond to here. There's going to be a bond there. It's going to find those up somewhere, and so that's going to be in a future lesson. Okay, so fluorine here, you write the F, write 7 dots. Right, now I want to start from the top. That's fine. Start from the top. Pick to go. If you like the counterclockwise, go ahead. 2, 3, 4. After the 4th one, you start pairing them. 5, 6, 7. Look at that. 3 pairs and 1 lone electron. So the bonding, that's where it's going to happen. The bond is going to happen with this one. It's going to pick up another electron from this, and then we'll talk about that later. Okay. And let's go down to helium here. Helium is group 18, right? You would think it has 8, but no. Remember, helium is the exception with only 2 valence electrons. Okay. So we draw helium. See this one, because it's a full shell, it's a noble gas, so you'll oftentimes see it like this, helium He as paired like that. I mean, it wouldn't technically be wrong if you drew it like this, 1 on each side either. It wouldn't be wrong if you drew it. So it's not technically wrong, but you'll often see it like that. Okay? Everybody else is pretty straightforward. Like sodium is on group 1. It's got 1 valence electron, so you write nah, and you can put the dot really top, bottom, left, right, anywhere a dot would be appropriate. Okay, so that's that. And then so basically it's very simple. It's group 1 is the symbol. Let's say X is our symbol. It'll be 1 dot. Group 2, the group that's up here, group. Okay, group 2 would be 1 dot, 2 dot. Okay, group 13, I'm sorry, it'll be that symbol, and then 1, 2, 3. Group 14, let me move this, let me see it a little better there. Group 14 will have 1, 2, 3, 4. Group 15 will have X is symbol 1, 2, 3, 4, and then you start pairing. The pair doesn't matter where you start. You can start the pair up on top, is fine. So there's going to be a 1, 3 singles. Group 16, we'll have here, we got 1, 2, 3, 4, then you got 2 pairs and 2 singles. Make sure the pair look close enough so that it's it looks like a pair. Okay. I oftentimes have students do it like this and then do it like that, and it doesn't look like it's very paired. Okay, gotta make it look very paired. 17. The symbol, as I say that, do it better myself right there, closer. That looks like a pair, that looks like a pair, that looks like a pair, and then there's one single one down at the bottom right there. And that single one could be anywhere, on the top, bottom, left, right. So there's no right or wrong on the location of that single one. So group 18, except for helium, it's going to be 1, 2, 3, 4, 5. You already know it's going to be all 4 pairs. It is full. All right, so that's how electrons work. So it's fairly simple. You replace the X with the symbol of the element, and the number of dot corresponds with the valence electron, which corresponds. All right, pretty simple. So very minor to me.